Let's take a quick look at OpenBSD. So I have here a fresh installation of OpenBSD with no external tools installed, and we're going to just see what is included inside, which is quite a lot. First off, let's write a little bit of C code. So I'm going to open the ed editor, which is considered to be the classic Unix editor. Even though we also have here VI, I'm going to use ed just to take a quick look at that. We're going to start by writing some code. So I'm going to run the append command. That's going to be A. Afterwards, we can start writing text. So I'm going to start by including stdio. Then I'm going to start my main function. Let's print something to the screen. For example, hello world. Afterwards, we finish off with a single line with a dot. This will tell ed that we're back to running ed commands. Now I'm going to run the write command. So that's going to be W for write. And then I'm going to pass in a file name. Let's call it main.c. Afterwards, ed is going to tell us how many bytes it wrote. And finally, I'm going to quit with the q command. Now we're back in the shell, and I can run the cc command. Let's take a look at the man page. You can see that cc runs clang, so it uses the clang compiler. I'm going to run cc on main.c. Output is going to be main. Now I can just run main, and it works nicely. Another cool thing is that OpenBSD comes built in out of the box with GDB, so you can just run GDB. It's going to open the GDB debugger. You can see that it runs quite an old version. It's 2004, but this is included inside of the source code of OpenBSD. You can of course grab the updated version of GDB by using the built-in package manager, but this comes built in. Just select the file we just made and run it. Works nicely. Quit with Q. Another thing we have built in is X11. In fact, OpenBSD maintains its own version of X11 that is more minimal than the main one. I'm just going to start it by running start X. It comes with this default window manager, but of course you can easily replace it by just installing whatever you want. Now let's go back to the terminal. So I'm going to exit this. And then I'm going to press somewhere here on the background. And finally click here on exit. And click again exit. By the way, OpenBSD comes with a bunch of games out of the box. You can just take a look by running ls and then user games. So for example, let's try out, I don't know, snake. You have to avoid the snake by using the arrow keys, collecting the dollars over here. The documentation on OpenBSD is actually really good, and you're going to find it on the website by going to FAQ. Or even here in the man pages. For example, I can run man and then release. And you'll get here information about how you can build OpenBSD, the source code. Another cool thing is you can run man and then boot, for example. And you'll get information about the boot of OpenBSD. Very interesting. You can also get man pages for functions that you can call from your code. For example, scanf, and we'll get documentation for this. Or for system calls, for example, I don't know, like man2 write. By the way, I put 2 because 2 is the category of system calls. And if you want to get more information about this, just run man and then man. And you'll see all the categories right over here. It's called sections. You can see that the section 2 maps to system calls. You even have a section for games, so that's going to be section 6. So for instance, if I just run man and then snake, you'll see that this is snake 6. That's because 6 is a section of the games. By the way, to add new packages, we can use the built-in package manager. That's called pkg. So just run pkg and then add, and then whatever package you want. For example, vim. We're going to need to tell it which option we're interested in. I'm going to choose option 6 to be vim with no X11 support. And now we have vim. Now let's go ahead and take a look at something cool about the kernel of OpenBSD. So for this, I'm going to reboot the computer by running the reboot command. Now when you get this prompt, you're going to want to press something on your keyboard because you're going to want to stop the boot at this stage. This is still the bootloader, or else it's just going to continue and boot the system. But I want to give it a command before it boots. So you can run here, for example, help. And you'll see the available commands of the bootloader. For example, we just have here echo, so echo hello world. This will work nicely as expected. Another command we can try out is the hexdump command. And we're going to use that to take a look at the MBR. MBR stands for master boot record. And when you have a bootable disk, at least in the old style before UEFI, is that you have the first sector on the disk, which is called the MBR or master boot record. And that is where the BIOS is going to load the initial code that will eventually boot the system. Now the thing is that the BIOS loads this code in a specific address in memory, and we can go ahead and read that address using this hexdump command. And we're going to identify this MBR specifically, and I'm going to show you how. So we're going to start by running hexdump, passing in the address in memory, and we know that this is loaded into the address 7C00 in hex. Finally, we know that the size of the boot sector is 512 bytes. Now we go ahead and run this, and you can see here a string that is related to the boot. You can see the string loading. This gives a hint that this is indeed related to the boot sector. But what really tells us that this is the boot sector is the fact that we can see here that it ends with 55AA. And this is a special magic number which identifies the end of the MBR. Now let's go back to the help over here. And specifically, I'm gonna run the boot command, but I'm gonna pass in -s, which means boot into single user mode. Now let's go ahead and do that. By the way, all these blue messages mean that these messages are coming from the kernel, rather than from user mode. Okay, cool. Now it's finished booting and it's asking me for the path of the shell or just return for sh. I'm going to use sh. That's going to be just a regular shell. And now I can start running commands. First command I'm going to run is sysctl, system control. And then I'm going to pass in ddb.console equals 1. Now, what is DDB? DDB is the kernel debugger that is built in the source code of OpenBSD. And console is an option that tells me that I can open the kernel debugger on demand from the console. I'm setting this to 1. So I'm going to run this. And now I can start the kernel debugger console by pressing on Control Alt and then Escape. And you can see that now we get a blue message again. This is a message from the kernel. And DDB is waiting for a command. So now I'm talking directly with the kernel. And I can start by running, for example, help. And it'll show me the available commands. Let's put a breakpoint, for example, on the exit system call. So when a process is exiting, we'll get a breakpoint. For this, I'm going to use the break command and pass in sys_exit. This is the name of the function in the kernel source code that is called when the system call of exit is engaged. Now I'm going to use the C command to continue execution. And we can see now we're back in the shell normally. And the way I'm going to trigger this exit is I'm going to run another instance of sh. So I'm going to run again sh. And now I'm going to exit. But I'm going to pass in a specific number which I'm going to search for later in the debugger. So let's put here, for example, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, whatever. And now we got a breakpoint at sysexit. And we'll take a look at the stack. And again, I'm going to run help here. See the available commands. And we can use the x command to examine. Specifically, I'm going to examine, I don't know, like numbers, whatever. So /d, decimal. Now you can notice here that the syntax kind of has like GDB vibes, but not exactly. Anyway, I'm going to use the ESP. ESP is the register that holds the address of the stack. And we know that we're in x86, 32 bits, so the arguments are passed through the stack. And I'm just going to continue pressing enter until we see this value of 1 until 8. This will just show me more values from the stack. And there it is. 1, 2, 3, 4, 5, 6, 7, 8. Exactly what we passed into the exit command. Now, one last funny thing that we can find here in the kernel debugger is that if we go again to help, notice a specific command that stands out. It's called hangman. What is hangman? So let's go ahead and run hangman. And you can see now we got into this sort of game running inside of the kernel debugger. And I can start typing letters on my keyboard, for example, A. And you can see that the hangman is starting to build up. E, that's wrong again. We got it right with the O. And the funny thing about this hangman game is that these symbols are actually coming from the kernel source code. So these are kernel functions, and you're playing hangman to try to figure out what the functions are. Another funny thing about this quite complicated hangman game is that you're basically stuck inside of this game until you win. If you remember the user games directory that he showed you earlier, you can play the user mode version of hangman, which will not take over your entire computer, and you can even practice with the kernel function names. Also, one more thing to wrap up. All these BSD derivatives like FreeBSD or NetBSD or OpenBSD, those are the three major ones. They're all derived from an operating system that was called BSD. And the history of this whole deal is that AT&T basically, Unix was invented in AT&T labs in the 60s. And then AT&T decided to license the source code for a bunch of companies and universities. One of those universities was Berkeley University in California, and they made BSD, Berkeley Software Distribution.